Hello everybody, welcome back to another video, and today we're going to be going over the basics of real analysis, specifically in this video, epsilon-delta proofs. So here I have an epsilon-delta proof, which is the limit as x approaches 2 of 3x plus 1 equals 7. So we need to prove that this is the case. Of course, you could just plug in the number 2 and get 7. However, for real analysis, you'll need to have a deeper level of thinking than this. So every epsilon-delta proof starts with pretty much the same thing, is for all epsilon greater than 0, there exists a delta greater than 0 such that, and then this other stuff is what changes depending on, of course, your problem that you have. So here we have zeros between, or what's it called? The absolute value, or in this case, the distance. So the distance here is x minus 2, the absolute value of x minus 2. So that's a distance of 2 from x. And that is in between 0 and delta. And it also, we have to also prove that the absolute value of the function minus actual limit that we get as a result is less than epsilon. So the goal is to simplify down and relate delta to epsilon. So let's look through it. We have our current information. So the first thing you want to do when you prove something is we're going to let epsilon be greater than 0. And we need to find a delta that controls how close x must be to 2 so that it stays epsilon, which is a very, very small amount, units away from 7, the actual answer. So when we plug in our function here, we have 3x plus 1, which is the function from up top, and then minus 7, which is the answer to our limit. And this, we can simplify it down. Of course, we can have 3x minus 6. And what's even cool about this problem is that here we can factor out a 3, and we can get x minus 2. And this will be very important in relating it back to this x minus 2 up here. So we want this to be less than epsilon. So let's divide both sides by 3. And then we get that the absolute value of x minus 2 is less than epsilon over 3. So then, after you do the simplification, we're going to let delta equal epsilon over 3. And if x minus 2 is in between 0 and delta, then this means that 3 times x minus 2 is less than 3 times delta, which is of course also equal to epsilon over 3. And 3 times delta, or epsilon over 3, is equal to epsilon. So this finishes the proof, and you can also make your little box right there. So just a little recap of what happened. So we have a limit right here, and we are trying to prove that this limit is correct. So for all epsilon greater than 0, there must exist a delta greater than 0 such that our distance from our limit, which is x minus 2, what that would be, is between 0 and delta, and the distance between the function and the answer to the limit is less than epsilon. And our first step in the proof was to let epsilon be greater than 0, simplify down our statement about f of x minus our limit answer is less than epsilon, relate it back. So we're going to essentially let delta equal whatever we get at the end of this, and then relate it back to our statement we made earlier, simplify things down, and then at the end, if you get epsilon, then that means that you have successfully proved it. Anyway, I'll see y'all later.